How's it going, everyone? Welcome back to the channel. My name is John. I do regular videos on space and Artemis and all that good stuff. And today we're going to be talking about how Voyager has just crossed the true edge of our solar system, and NASA's latest data actually shows something nobody expected. We're talking about strange particle behavior, unusual magnetic conditions, and a boundary that acts like a real wall. So today I'll show you exactly what Voyager has discovered, what the edge of the solar system actually is, and what this means for the future of deep space travel. So let's get into it, guys. Voyager 1 and Voyager 2 launched all the way back in 1977. They were both built to study Jupiter, Saturn and the other outer planets. But here's the crazy part: their most important discoveries didn't happen near the planets at all. They actually happened decades later, in a part of space humans have never reached before. Voyager travels so far that it reached the boundary where the sun's influence ends and the galaxy actually begins. So let's simplify this. The sun constantly blasts out charged particles. That's called the solar wind. And that solar wind creates a massive bubble around our solar system called the heliosphere. Think of it like this. The heliosphere is a protective bubble. It shields us from dangerous cosmic radiation, and it's created by the sun's magnetic influence. So that bubble has an edge, and that edge is called the helopause. Now here's when it gets wild. When Voyager 1 crossed the helopause back in 2012, its instruments detected something dramatic: a sudden drop in solar particles, a sudden increase in cosmic rays from deep space. In other words, Voyager basically said, yep, I'm outside the solar system now. Then years later, Voyager 2 crossed it too, but from a completely different direction, and it confirms the same thing, because now scientists actually had two separate measurements of the edge of our solar system. So what NASA actually expected versus what Voyager then found. Before Voyager, scientists assumed the boundary would be messy, like a thick cloudy zone where everything slowly mixes together. But Voyager didn't find that. Voyager found the opposite: a sharp boundary, almost like flipping a switch. One moment solar system conditions, the next moment interstellar conditions. That means the helopause isn't just a theory, it's a real structure, a real physical boundary in space. And Voyager actually measured it. So this is the shocking part. Voyager also detected something else. A region just inside the helopause where particles get compressed, heated, super energized, almost like a pressure zone. Temperatures and particle density were way higher than expected. So instead of the solar wind gently fading away, it looks more like the sun slams into the interstellar medium and forms a kind of boundary layer. So Voyager basically showed scientists this edge isn't calm, it's energetic, it's active, and it's alive. So why does this matter? Now here's why this is more important than most people realise. Outside the heliosphere is cosmic radiation, and these are particles moving near the speed of light. And these come from things like supernova explosions and extreme galactic events. And Voyager actually proves something very important. The heliosphere blocks a large amount of that radiation. It acts like a shield, so if humans want to go deeper into space, Moon, Mars or beyond, this matters a lot, because radiation is one of the biggest dangers astronauts can face today. So the Voyager data actually helps NASA build better models to predict the risk. One of the strangest surprises Voyager found involves magnetic fields. Scientists predicted the sun's magnetic field and the galaxy's magnetic field would smash together. Instead, the magnetic field on both sides of the boundary looked more aligned than expected, which suggested something even more mysterious. These fields might be interacting, reorganizing, and even connecting, and honestly we still don't fully understand it yet. And that's what makes Voyager so exciting, because it's not just sending back cool facts, it's sending back problems that our old models can't fully explain. And the biggest one is this: the helopause isn't a gentle boundary, it's more like a physical structure. On one side, solar particles dominate, the sun's plasma controls everything, and then suddenly, the moment Voyager crosses over, all of that drops away and interstellar space takes over. So Voyager didn't just prove we can leave the solar system, it proved the solar system has a real edge and a measured one. And here's where the wild part actually kicks in. Voyager detected something happening right at that boundary, a compressed superheated region just inside the helopause. It's almost like the solar wind is being slowed down, crushed and heated as it's pushed against the Milky Way. That means the edge of our solar system is not calm, it's energetic, it's active, and it changes over time. Now you're probably wondering, why the hell does this matter for us down here on Earth? Because the heliosphere isn't just a bubble, it's protection. Outside the heliosphere is a flood of something called galactic cosmic rays. These are particles created by distant supernova explosions and violent events across the galaxy, and they travel near the speed of light. And Voyager proves something massive: As soon as it crossed the helopause, cosmic radiation rose sharply. Solar particles nearly disappeared. That means the boundary is acting like a filter, separating two completely different radiation environments. And if you ever want humans living on the moon or travelling to Mars, this means a lot, because cosmic radiation is one of the biggest threats to astronauts. But the bigger story is what this means for the long term. The sun isn't standing still. Over millions of years, our solar system moves through the Milky Way, through regions with different densities, different magnetic activity, different conditions. And if we ever pass into a denser cloud of interstellar gas, the heliosphere could actually shrink, and that could allow more cosmic radiation to reach the inner solar system, meaning potentially more radiation could be reaching the Earth. So Voyager isn't just telling us about the edge of space, it's giving us a glimpse of the future environment of our entire solar system. And this is why Voyager might be triggering the next big NASA mission. Voyager's instruments are over 40 years old, and yet they're still rewriting what we know. So imagine what a modern interstellar spacecraft could do. With today's sensors, cameras and instruments, a probe designed to specifically map interstellar space could measure magnetic fields, particle flows, radiation pressure, and even the chemistry of the interstellar medium. So here's the best part. Voyager is still out there right now, still transmitting. Engineers are slowly shutting down systems to save just enough power to keep the signal alive as long as possible. And every signal NASA receives is literally a message sent from the space between the stars. So you're probably wondering why Voyager data is hard to receive. And here's the part most people don't realise. Voyager isn't sending back a clean HD stream or anything like that. The signal is unbelievably weak. By the time it reaches Earth, it's so faint like it's trying to hear a whisper from the other side of a continent during a hurricane. That's why NASA uses the Deep Space Network. These are giant radio dishes across the world, and they work together like one massive ear. And even then, it can take hours just to confirm the signal and separate the real data from the background noise. So when Voyager phones home, that's not just a cool headline, that's one of the most impressive communication achievements in human history. And it gets even crazier when you think about the delay, because Voyager is so far away now that when it sends a signal, it doesn't arrive instantly, it takes hours. So when NASA sends a command to Voyager, they're basically sending a message into deep space and then waiting and hoping the spacecraft still responds exactly the same way they predicted. It's like trying to control something on the other side of the solar system with zero room for mistakes. And this is why Voyager is still teaching us something important today. It proves that exploration doesn't stop once you build the rocket. Real exploration builds when you keep the mission alive, keep the systems running, and keep pulling the knowledge out of the unknown. Voyager's instruments may be old, but what it's discovering is brand new. And the region beyond the helopause, that's not empty, it's structured. It's alive, and it has pressure, particles and magnetic fields that are shaping the solar system's outer edge right now. And here's what I love most about this mission. Voyager doesn't just show us how far we can go, it shows us how curious humans really are, because even after nearly 50 years, we're still listening, still learning, and still getting messages from the outer space between the stars. So that's all I got for you for today, guys. Thanks again for watching, hope you enjoyed the video, and I'll see you in the next one. Take care, cheers.